Good afternoon. Today we are going to be going over our 2.4 notes, which talks about continuous and discrete functions. Our learning target today is I can determine reasonable domain and range values from discrete and continuous linear situations and justify my thinking. So today we're going to be talking about two very specific types of functions. We have continuous functions and discrete functions. A continuous function, we're going to talk about, when we talk about these vocab words and when we look at the examples that we have today, we're going to focus on two different types of each of these functions. We're going to look at what a continuous function is in terms of a word problem and then in terms of a graph, and then we're going to look at discrete problems in terms of word problems and then again in terms of graphs. So when we talk about these vocab words, we're going to talk about both what you'll see in a graph and what you'll see in a word problem. So just keep that in mind as we go through this today. So a continuous function will be a graph that is unbroken. Your graph is unbroken. And your word problem will contain any value. So when I say any value, I'm talking about whole numbers. I'm talking about decimals, things like that, okay? So an example of a continuous graph would be something that looks like this, okay? Your most basic line graph would be a good example of a continuous function. Now, I do want to point out that continuous function graphs do not have to have arrows on them. They do not have to go on forever. I can give you another example of a graph that looks like this. That is also a continuous graph. This one has restrictions on it, meaning that it is continuous within the data points that we have. So basically from this point to this point, my graph is unbroken. Okay, even though it doesn't continue on past those dots, within the boundaries or within the restrictions of my graph, I do have unbroken data, okay, or unbroken, it's unbroken data, okay. A word problem will have any values. You'll see decimals, you'll see whole numbers, you'll see fractions, you'll see any possible thing that you can think of, you're going to see. A discrete function is going to have a graph that is broken, and a word problem that contains specific values. And when I say specific values, we are really going to focus mainly on whole numbers. So a discrete function graph is going to be a bunch of dots on your graph. This is what we mean by broken. So in between dots on this graph, there is no other data. So you can look at this graph and say, I definitely know where all of my data points are. When you look at a continuous graph, you can see where some of your data points are, but there are so many of them that it's impossible for you to name all of them. When I look at my broken discrete graph, I can look at that and tell you very specifically what every single one of my data values are. We're going to talk about continuous and discrete functions in terms of our word problems. So it says determine if the following word problems are continuous functions or discrete functions, explain how you know, and then list possible domain and range values. So when you look at number one, it says a store sells pizza by the slice. Each slice is $3. So the question is this continuous or discrete? So imagine that you're going up to the counter at a pizza place and you say, I would like to buy 4 slices of pizza. Well, you can buy 4 slices of pizza, you can buy 10 slices of pizza, you can buy 1 slice of pizza. But what you can't do is buy a half slice of pizza. You cannot go to the counter and say, I would like 1.5 slices of pizza. You can only order pizza by whole slices. So because you cannot contain any half values, we would say that this is discrete. Okay, and off to the side, oh, I guess I can put it down here, you have no half slices. So instead of it being any possible value, we are kind of stuck to only having whole number values, which is why this one is going to be considered discrete. Now, when we talk about domain values, we are going to talk about the number of slices of pizza. So when you go to the counter, you can buy 1 slice of pizza, or 2 slices of pizza, or 3 slices of pizza, and so on and so forth, okay? But remember that you can't buy 1.5 slices of pizza. Now, if I bought 1 slice of pizza, that would be $3, which is going to be my range, okay? If I bought 2 slices of pizza, that would be $6. If I bought 3 slices of pizza, that would be $9. And again, it's going to depend on the domain values or the number of slices of pizza that you buy, okay? So I want you to think about this. If you are looking at a word problem, if you can have halvesies of things, then it is not going to be discrete, it will be continuous. If you cannot have halvesies of things, then it's going to end up being discrete. With that in mind, let's look at number 2. It says, when making cheese, the weight of the cheese depends on the number of gallons of milk used. Each gallon of milk produces 1.5 pounds of cheese, and you can only make 10 pounds of cheese max in one day. So when I think about milk, and when I think of weight, like pounds, when I think of milk, like think about milk in a gallon, or think about water in a gallon jug, okay? When you go to pour yourself a glass of milk, do you have to pour yourself the entire gallon at one time, or can you pour out like half a gallon, or a fourth of a cup, or half of a cup, or a teaspoon? Because you are able to use various amounts of milk, or you can have various amounts of weight of your cheese, and they don't have to be whole numbers, we can actually say that this is going to be continuous. And you can say, can have half gallon. You could literally just use like a splash of milk if you wanted to, okay? That would be like 1/87th or something, okay? So because you have this wide range of numbers you can use, you could use a splash of milk, you could use a fourth of a cup, you could use a half gallon, you can use a whole gallon. It's going to be really difficult for us to list all of the possible values because we have, for the most part, an infinite number of values that we can use within the gallon of milk that we're looking at. So instead of listing our domain and range in a set like we did for the discrete function above, we're going to have to use inequalities to represent all possible values, just like we have been doing in previous notes, okay? So a possible domain value, this is going to be the number of gallons of milk used. So we can use anything that is greater than or equal to 0. Okay, now here's where things we have to kind of figure this out, okay? I do have a max amount of milk that I can use because it tells me that I can only make 10 pounds of cheese max in one day. So if 1 gallon of milk produces 1.5 pounds of cheese, I need to figure out by multiplying, I have my calculator over here, I need to figure out by multiplying the maximum amount of gallons that I can use in one day as well. So, it looks like 15 is going to be the maximum amount of gallons that I can use. So what this is saying, the way this inequality is written, it's a compound inequality. We talked very briefly about compound inequalities in the last couple sets of notes. What this is saying is, oh, I used the wrong variable. Whoops-a-daisy. I should have used x. Okay, remember that domain values are your x values. I wasn't paying attention. Okay. So what this inequality is saying is the gallons of milk used can be literally anything between 0 and 15. So let's choose a really easy number. I could say 7. Is 7 between 0 and 15? Yeah, so 7 works for my x value. However, when I get to maybe saying like half a gallon, could I put a 1/2 in there for x? Yes, I could. Could I put 1/4 of a cup in there for x? Yes, I could. So because I have all of these different pretty much infinite options when it comes to the gallons of milk, and I can't list them individually, I'm going to use this compound inequality, okay? Now, the range values are going to work very similar to that. Again, I'm going to start at 0, and that represents the amount of cheese I have. And then the maximum amount of cheese that I can have is 10 because it tells me that. But could I only make 1.5 pounds of cheese? Sure. Is 1.5 between 0 and 10? Yeah. Can I make 10 pounds of cheese in one day? Absolutely. Could I make 0 pounds of cheese in one day? I mean, theoretically. Could I make a crumb of cheese in a day? Yes, absolutely. So because I have all of these possible answer choices that I can't list because there's just too many of them, I use inequalities to represent my domain and range here. So that's going to be the difference between a continuous and discrete word problem. Okay, we're looking for halves. Can you have a half of something? Yes, great. All right, so now what we're going to do is we are going to move down to looking at graphs, determining whether my graph is continuous or discrete based on if my data is broken and unbroken. And then in this first section, we're going to determine whether or not these graphs represent a function. We're going to do something very similar down here, but we're going to also list the domain and range, okay? So when you look at these first 4 problems here, I need to know whether or not they are continuous or discrete, and then again, whether or not they are a function. So it tells me up in the directions that continuous graphs have unbroken data, and then discrete graphs have broken data. So when you look at number 1, I do not have a line that connects between my dots that I see on my graph. So because there is not unbroken data in between coordinates, everything is broken, I can list my values very specifically. This is going to be considered a discrete graph. Is this a function? Well, does this pass the vertical line test? Yes. Anywhere that I draw a vertical line, my vertical line is only going to interact with those coordinates one time. So we would say yes. And then we would say for the reason, we say that this passes the vertical line test. If I move over to example number 2, again, this is all broken data. That means that it is discrete. Is this a function? This one will not be a function. If I draw a vertical line on all of these coordinates here, they all touch one time except for the very first option that I chose. Notice that when I draw a vertical line on this graph, it actually intersects 2 points, which means that this is not a function and it fails the vertical line test. When I move down to example 3, my graph is here. Does this graph contain broken or unbroken data? It contains unbroken data, so that means that it's going to be continuous. Is this a function? No. This fails the vertical line test. Remember that vertical lines, hold on, there we go. Vertical lines cannot pass the vertical line test because when you draw a vertical line on top of another vertical line, like I have done on this graph, your 2 vertical lines are actually touching an infinite number of places. So it fails it an infinite number of times. Looking at number 4, is this continuous or discrete? I know that I have an endpoint here and an endpoint here, but between those 2 data points, my graph is unbroken. There's nothing else that, those 2 dots are connected to each other by a line segment, okay? So because of that, this is technically unbroken data, and that means that it is a continuous function. Is it a function? Does it pass the vertical line test? Yes, it does. So my Y would be that it passes the vertical line test. Again, I could choose anywhere to draw a vertical line, and no matter where I draw this vertical line on my graph, the graph will only touch my vertical line once. Okay, now what we're going to do is we're going to come over here and we are going to list the domain and the range of discrete graphs. This set of notes does not contain domain and range of continuous graphs because it is much more complicated than finding the domain and range of discrete graphs. So all we're doing today is focusing on whether word problems are continuous or discrete, and then focusing very specifically on the domain and range values of discrete graphs. Okay, so when I take a look at number 1, I need to list the domain and range. Remember that the domain are all of the x values that are contained within your graph, and your range are all of the y values contained within your graph. When you look at your graph, can you name every single x value individually? Can you name every single y value individually? The answer is yes. I have very specific coordinates on my graph. My graph is full of broken data. I can see where every single coordinate is on this graph. So because of that, I am actually able to list my domain and range values in a set. Now, my suggestion for you is to actually come over to the side of your graph and write down each one of these points as a coordinate. It's going to help tremendously for you to label the x values and the y values. I always start on the left of my graph and then make my way to the right. So I'm going to start with the far left coordinate first. So that coordinate is at 1, 2, 3, 1, 2, 3. So that coordinate is at -3, +3. And then I'm going to move to the one directly next to it. That's at -2, +2. The next one is at the origin, 0, 0. The next one is on the x-axis at 2, 0. And then the last one is at 1, 2, 3, 4, 1, 2. It is at 4, -2. And now that I've been able to list all of my coordinates, remember that your domain values are all of the x values, and your range values are all of the y values. So now we can take those coordinates and just list them. -3, -2, 0, 2, 4. And then my range values will be, I'm going to start at -2, 0. I'm only going to write 0 once. You do not have to repeat any repeating coordinate, any domain and range values. And then when you look at your graph, you just ask yourself, is this a function? Does this pass the vertical line test? My answer is yes. This is a function. This for sure passes the vertical line test. I can draw a vertical line anywhere on here, and it's going to touch those coordinates only a one time. Sorry if you hear weird noises. My dog is next to me, and he's weird. Okay. All right, this is a discrete graph. I can very specifically name every single coordinate that I see. So I'm going to write those coordinates down off to the side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I always start with the far left. It doesn't matter where you start. That's just where I start. 1, 2, 3, 4, 1, 2, 3, 4. So we again have -4, 4. And then I've got -2, 1, 2, 3. I've got -2, 3, and then -2, 1. I've got 0, -2. I've got 1, 2, 3, 1, 2, 3, 3, -3, and then I've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I've got 5, -5. My domain values are the x values, and my range values are the y values. So I've got -4, -2, 0, 3, and 5. I'm not going to repeat that repeating -2. You can if you want to. Your range here is -5, -3, -2, 1, 3, 4. I try really hard to keep my domain and range in numerical order. I don't always do that, but when I can, I try to. This fails the vertical line test, so this is not a function. Vertical line test. All right, and then I'm going to go ahead and skip these last two because I think that you have a pretty good understanding on whether or not these graphs are functions, and then also listing the domain and range specifically of discrete graphs. I will finish this for the sake of the notes key, but that is the end of the video. As always, if you have any questions or need any assistance, please go see your teacher during their normally scheduled tutorial times, and I will see you the next